All right, so a couple of things. First of all, let's go back to yesterday, especially for those of you who were not here. Can somebody tell me again what is standard form of a quadratic? Ax squared plus bx plus c. Did you not get to this? Okay. Now, a couple of things. It was said over here earlier, I love it. The ax squared term is your quadratic term. Anybody know what the bx term is called?
Linear.
My linear term. And how about the c?
The constant.
The constant. Did you guys do that yesterday? You guys just know.
We didn't.
Awesome, good. We're going to touch more on that tomorrow. Now, obviously, we're not going to get our iPad out here to do this stuff because anybody have their iPad?
iPad. We're not allowed to have iPads.
Did anybody go to that? Anybody go to that sale?
No.
No, there was like a line.
It was like Black Friday.
It was.
It was. I'm so glad I did not go to it, although I still have my iPad. I probably shouldn't have that on tape, but
Wow.
because we're using it for school educated purposes. Okay. Now, the standard form is easy in some respects. It's easier for the y-intercept. It's probably easier to plug stuff in, but you're going to find today to be a lot easier. Now we're talking about vertex form. The vertex form is y equals a times x minus h squared plus k. That's a k. My k's are always messed up. That is a k. Now, first thing I want you to recognize is, what do they have in common? They have squared and the a, right? And the a is exactly the same in both of them. We said it earlier, a determines whether it opens up or down. And it's the same thing in both forms. The squared has to be there because they're both quadratics. Okay. Now, from there, there's a few things that make this really easy. The first thing is the vertex. The vertex is very simple. In the other form, remember we had to take the opposite of b over 2a, and then you had to plug that in. Well, this is vertex form. So it gives you the vertex, which means the vertex is simply h. Okay. That's it. It's that easy. It's right in the problem. Now, what I want you to recognize, though, is that's a minus sign. So if I have x plus 1, really that means x minus negative 1. Everybody see that what I'm talking about there?
Yeah.
I mean, zip zap, right? But give me a plus sign. So the vertex is always kind of opposite, same. Okay. By opposite, I mean the opposite of what you see inside and the same of what you see outside. So what's my vertex in number 1?
It's negative 1, 4.
Boom. Just like that. Okay? So, you know what? Let's go and just graph that right away. Negative 1, negative 4, down here. Okay? Now, the axis of symmetry. Anybody think they know what it is? Okay, well, how do you say it? X equals negative 1, right? You're going to lose a half point on a quiz if you don't say x equals. Because if you just say negative 1, that's a point. If you say x equals, that is a line which gives you your axis of symmetry. So up here, let's say x equals h, because we should know that the vertex point always gives you the axis of symmetry. It is in both forms. It is always that way. Okay? How about the y-intercept? Well, what did we have to do? What do all y-intercepts have in common?
They are. Their x is 0.
Their x is 0. They're all on the y. I think that's where you guys are going. And yeah, the x is always 0. So, I mean, I can put that up here. Let's y int is 0. Well, let's write that down here, 0. Is it 0k? Remember yesterday it was 0c. You know why it was 0c? Because if I plug in 0, that goes away, and I'm just left with this. That's why. It's not just because it's automatically c. If I plug in 0 here, am I going to get just negative 4? No, not always. Maybe sometimes it happens, but so you plug it in. That's exactly right. So I'm going to put 0, plug in. That is also known, by the way, as f of 0. If you don't remember that, I'm going to reference it on the back side. That'll come later, but it's function notation for plug in 0. Okay? So we've got 0. Let's plug it in. And I'm going to show you a lot of work here on this one, and then from now on I'm not going to after that. But it's just plug it in. 0 plus 1 squared minus 1, or minus 4, excuse me. And what do I do first in this problem? Parentheses. Good. 1 squared minus 4. And then exponent, which is super important here, because if I take 2 times 1 and square it, I get 4 times 4, or minus 4 is 0, and that's not what we're doing here. We gotta do the exponent first, and then 2 minus 4 is negative 2. So I've got, and you don't have to do this, but if you do it, I'm not gonna count it wrong for sure. I've got my axis of symmetry right here, which is nice to have, because when I plot 0, negative 2, well sweet, I can just reflect it over here. What do all reflection points have in common?
The same distance away from the axis.
Yes, and what else? I heard someone say it. The y value, right? It has to, because it's not going up or down. That I could do right away. And it just so happens that once I reflected it, look, I just label that point, negative 2, negative 2. Sweet, got it. Any questions so far? Now, let's look at point, and I gave you one. What do you think I do with one? Plug it in. So let's do it, okay? I'm going to show less work here. I'm just going to go 2 times, well, if I plug in 1, I get 1 plus 1, which is 2 squared, which is 4, minus 4, I get 8 minus 4, which of course is 4. So again, because I know the reflection point better have a 4 right there, I could fill that in right away, but I don't need to, because I can go plot 1, 4. And like Keegan said, I go the exact distance away from that, so I'm going to go 2 this way, and I just identify that point, negative 3, 4. It better have the same y value, and it does. Now, of course, I can connect my dots. If I'm going too fast, stop. I'll stop right there for a second. And then I talk about increasing and decreasing, okay? What should I do with increasing and decreasing? Can somebody tell me where it's increasing?
Oh, x is greater than,
How do you know that?
or negative 1, because it's going up from negative 1.
There you go, that's it. It's going up from negative 1. And again, I could just right away, when I did my axis of symmetry, I could have filled that in right away. And then once I graphed it, I can see, oh, it's going uphill after negative 1. It's going downhill before negative 1. What do you think? Easier than the other one?
Yeah.
I think so too.
How'd you get the 4 with the point 2, 4?
Are you talking about from my point right here?
Yeah.
I plugged 1 in up here, and 1 plus 1 is 2, and 2 squared is how I got that 4 right there.
Okay.
Okay, good question. Anybody else? You guys try number 2.